I'm going to solve a series of problems to test your understanding of these basic set operations. Suppose we have a universal set consisting of the elements 7, 8, 9, 10, 11, 12, and 13. Remember, the universal set is the superset of everything that is possible in a particular context of a problem. So the only numbers that are possible are the numbers listed in the universal set. Set A consists of the elements 8, 10, and 12. The set B consists of the elements 10, 12, and 13, and the set C consists of the elements 7 and 8. First question, what is A union B? Now when I take the union of two sets, I look at the elements that appear in either of the two sets. And it's nice to write them in order. It's not necessary. Order doesn't matter in a set, but it certainly is nice to write them that way. So I'm looking in A and B. The smallest number I see is an 8, so I'll write that first, even though I don't have to. Then I have a 10. It doesn't matter if it appears in both. If it appears in either or both, it goes into the union. And I have a 12. And in B, I have a 13. So if it appears in either or both, then in fact it is in the union. Next question. What does A intersect B? Now the intersection are the elements that are in both A and B. So if you look back up here at A and B, 8's in A but not in B, 10's in both, 12's in both, 13 is only in B, not in A. So the intersection of A and B consists of the set with elements 10 and 12. Third question. A union B complement. Now the complement of the set are the elements in the universal set that are not in the set that's being complemented. So here I want to find these elements that are not in B but are in the universal set. So let's actually write this out. Let's carefully write this out. I will first just write out what A is. It's better to take your time and be careful. Union. Now B complement consists of everything in the universal set that's not in the set B. So I'm looking. 7 is in the universal set but not in B. 8 is in the universal set but not in B. 9 is in the universal set but not in B. 10 is in B, so it doesn't go in. 11 is in the universal set but is not in B, so 11 pops in. 12 is in B, so it doesn't go in. And 13 is in B, so it doesn't go in. So B complement, and again, 7 is in there because it's not in B, 8 is in there because it's not in B, 9 is in there because it's not in B, 10 is not in there because it is in B, 11 is not, so it goes in, 12 and 13 are both in there, so be very careful. So now I'm taking the union of those two things. Union means either. So if it's in either set, it goes in the union. And again, order doesn't matter in a set, but it's certainly nice to write them in numerical order when it's practical to do so. So 7 is the smallest thing that's in either. 8 is the next smallest. 9, 10, 11, and 12. And again, order doesn't really matter in a set, but it's certainly nice to write it that way. It's the natural way you expect to see it. So there is the union of A and B complement. And finally, we want to do the union of A and B complement intersected with C. Now if you just had this problem presented to you in the original, when you first started, you would work on the inside parentheses and get an answer there, and then you would do the intersection. And I purposely made the inside part here in parentheses of the previous problem to save me a little time. So this A union B complement, when I calculate it, I've already done it, and I don't have to reinvent the wheel. So if you're given that off the bat, you would have to do that calculation. But since it's the exact same thing that I just did up here, I can just copy it down. And now I want to intersect that with the set C, which consists of the elements 7 and 8. And again, intersection means the elements have to appear in both, and 7 and 8 appear in both. So the intersection of those two sets is the set consisting of 7 and 8.